a fruit found in lunchboxes, supermarkets and kitchens around the world. Soft, sweet, familiar, and radioactive. For decades, a curious fact has circulated through science classrooms, internet forums, and news articles. Bananas contain radioactive material. The claim is true, but the reality behind it is far more fascinating than most people realize. How can a fruit be radioactive? Does eating bananas expose us to radiation? Could eating too many be dangerous? And why do nuclear scientists sometimes use bananas as a joke unit of measurement? This is the story of the radioactive banana. Radioactivity sounds like something that should arrive with dramatic music and government paperwork. In reality, you're sitting in it right now. To understand radioactive bananas, we first need to understand radioactivity itself. Atoms are the building blocks of matter. Most atoms are stable. Their nuclei remain unchanged for billions of years. But some atoms are unstable. These unstable atoms spontaneously transform into different forms, releasing energy and particles in the process. This phenomenon is called radioactive decay. The unstable atoms responsible are known as radioisotopes. Radioactivity is not rare. In fact, it is everywhere. The rocks beneath our feet contain radioactive elements. The atmosphere contains radioactive gases. Even our own bodies contain naturally occurring radioactive isotopes. Every human being is radioactive. The question is not whether something contains radiation. The question is, how much? Bananas didn't ask for fame. Potassium hired the publicists. Bananas are famous for one nutrient above all others: potassium. An average banana contains roughly 400 to 450 milligrams of potassium. Potassium is essential for life. Without it, nerves cannot transmit signals properly. Muscles cannot contract efficiently. The heart cannot maintain its rhythm. Every cell in your body depends on potassium. But potassium comes in multiple forms, known as isotopes. Most potassium on Earth exists as potassium-39, potassium-41. Both are stable. A tiny fraction, however, exists as potassium-40, and potassium-40 is radioactive. Potassium-40 has been around so long, it remembers when continents were still trying to figure themselves out. Potassium-40, often abbreviated K40, is one of the oldest naturally occurring radioactive isotopes on Earth. It has a half-life of approximately 1.25 billion years. A half-life is the amount of time required for half of a radioactive substance to decay. To put that in perspective, complex multicellular life had not yet evolved when much of today's potassium-40 began its slow transformation. Despite its rarity, potassium-40 is found throughout nature. It exists in soil, oceans, plants, animals, human bodies, and of course, bananas. Only about 0.012% of naturally occurring potassium is potassium-40. That sounds insignificant. Yet because potassium itself is so common, measurable radioactivity exists almost everywhere. 15 radioactive decays every second sounds terrifying until you realize your own body is already running a much bigger atomic party. An average banana contains approximately 15 becquerels of radioactivity. A becquerel represents 1 radioactive decay per second. In practical terms, a banana experiences roughly 15 atomic decays every second. At first glance, that may sound alarming, 15 radioactive events every second. But context matters. The human body contains around 140 grams of potassium. Because some of that potassium is potassium-40, your body already experiences thousands of radioactive decays every second. Even if you never eat bananas, A typical adult contains approximately 4,000 to 5,000 radioactive potassium decays per second internally. The banana adds only a tiny, temporary increase. Congratulations, you are now the most radioactive thing in your immediate vicinity. Many people imagine radiation as something external. Nuclear reactors, X-ray machines, cosmic rays. But some radiation comes from within. Your bones contain trace radioactive isotopes. Your muscles contain potassium-40. Your blood carries naturally occurring radioactive materials. This has been true for every human who has ever lived. Long before the invention of nuclear power, long before the discovery of radioactivity, long before civilization itself, natural radiation is an unavoidable feature of life on Earth. In fact, life evolved in its presence. Humans have measured things using feet, inches, cubits, horsepower, and now, apparently, bananas. At some point, scientists and educators faced a communication problem. The public often struggled to understand tiny radiation doses. Measurements such as microsieverts seemed abstract. To make radiation easier to explain, a humorous concept emerged: the banana equivalent dose, often abbreviated BED. The idea was simple. If eating one banana exposes a person to a tiny amount of radiation, then larger radiation doses can be expressed as equivalent numbers of bananas. One banana corresponds to roughly 0.1 microsieverts. This comparison is not an official scientific unit. It is a teaching tool, a joke that became surprisingly popular. The banana equivalent dose is useful, but it also makes bananas sound like they're plotting something. Although useful for public outreach, the banana equivalent dose has important limitations. When you eat a banana, your body carefully regulates potassium levels. Excess potassium is removed through normal biological processes. As a result, eating a banana does not permanently increase the amount of potassium-40 in your body. The body maintains a near constant potassium balance. This means the radiation exposure from bananas is temporary and biologically managed. By contrast, many other radioactive substances are not regulated this way. Certain radioactive particles can accumulate in tissues. Others can remain inside the body for years. Therefore, comparing all radiation sources to bananas can sometimes oversimplify important differences. To receive dangerous radiation from bananas, you'd first have to solve the far greater challenge of becoming a banana processing machine. The obvious question follows: if bananas are radioactive, could eating enough become dangerous? Theoretically, yes. Practically, no. To reach dangerous radiation levels from banana-derived potassium-40 alone would require consuming impossible quantities. Long before radiation became a concern, the body would encounter far more immediate problems: potassium overdose, digestive distress, fluid imbalance, and other serious medical complications. In reality, radiation from bananas is so small that it is considered negligible. A commercial airline flight exposes passengers to vastly more radiation from cosmic rays. The Earth's natural environment exposes us to radiation continuously. Medical imaging procedures can expose patients to radiation doses thousands of times greater than that associated with a single banana. Bananas became famous. The potatoes are still waiting for representation. Bananas are not unique. Many foods contain measurable radioactivity. Examples include potatoes, beans, spinach, Brazil nuts, carrots, avocados. Plants absorb minerals from soil. Those minerals naturally contain trace radioactive isotopes. One especially notable example is the Brazil nut. Because of its deep root system, it can accumulate comparatively higher concentrations of naturally occurring radioactive materials than many other foods. The radioactive banana gained fame primarily because it became a memorable educational example, not because it is unusually dangerous. Atoms are notoriously bad at checking whether their radiation is natural or artificial before leaving the nucleus. One reason the radioactive banana fascinates people is that it challenges a common assumption. Many people unconsciously divide radiation into two categories. Natural equals safe, artificial equals dangerous. Reality is more complicated. Radiation is radiation. What matters is type energy dose, exposure duration, biological location. A gamma ray from a natural source and a gamma ray from an artificial source behave according to the same laws of physics. The banana reminds us that radioactivity is not an invention of modern technology. It is a fundamental feature of the universe. Forensic investigators can identify radioactive signatures. Bananas, unfortunately, leave fingerprints everywhere. Modern radiation detectors are sensitive enough to identify the potassium-40 inside bananas. Using gamma spectroscopy, scientists can detect the characteristic energy signature produced by potassium-40 decay. The signal is unmistakable. In fact, bananas are sometimes used in educational demonstrations to show that naturally occurring radioactivity can be measured in everyday objects. These demonstrations reveal an important truth. Radioactivity is not synonymous with danger. Detectability and hazard are not the same thing. Something can be measurable without being harmful. The banana may be radioactive, but compared to the age and scale of the universe, it's basically just a slightly glowing footnote. The radioactive banana is more than a scientific curiosity. It serves as a reminder that the world is filled with invisible natural processes. Every second, atoms decay. Cosmic rays pass through us. Radioactive isotopes transform. Life continues uninterrupted. The radiation inside a banana has existed for billions of years. The potassium-40 within it was forged in ancient stellar events long before the Earth formed. When we eat a banana, we participate in a chain of cosmic history stretching back to the birth of the elements themselves. So yes, bananas are radioactive. The statement is scientifically accurate. But the truth is not a story of hidden danger. It is a story of perspective. A story about the remarkable fact that radioactivity is woven into the fabric of nature. The next time you peel a banana, remember, inside that ordinary piece of fruit are atoms older than humanity, older than civilization, carrying traces of processes that have been unfolding since deep time itself. Not a threat, but a reminder of how extraordinary the ordinary can be. Thank you for watching, and please subscribe for more videos just like this.